Cory, over to you.
Hi, I have a lapel. Thanks. So I'm going to ask for the panel members to go ahead and introduce themselves. So if you just want to tell us a little bit about yourself.
Hi, is this on? Hello. Can you hear me? Should be what? Hello. Okay, hi, I'm Adam Laurie. I work for IBM X-Force Red. I'm head of hardware hacking. You may know me from my previous existence as an open source hacker developer. Major Malfunction is my handle. I've been in the scene for probably 20 plus years. So.
Hi, my name is Maggie. I work for Intel for a team called PAR, Platform Armoring and Resiliency, and basically we're the dedicated security research team for BIOS.
Hi, my name is Hemant Raju. I work for SmartThings. I'm Director of Security and Privacy Engineering. I've been working there for about a couple of years. Before that, I was at Walmart Labs in the same area. And before that, I was at Intuit. So I've been in this industry for about 20 years.
I'm Mike Shema. I lead the product security team at Square, and we work with our software and hardware stacks to figure out what are the interesting threat models, what are some common threat models, and how creative can we be about attacking and protecting software as well as our hardware stacks it's on.
So one of the things that they didn't mention in my introduction is that I'm actually relatively new to Google and into being responsible for what is partially a hardware security program, of course, with Google Nest. My background has been in software and services security in the past. Previously, I was responsible for security and privacy at LinkedIn. And so I'm going to use this panel as a fast track for me to get all up to speed with how to be the best security leader I can for hardware.
That's cheating.
And so, yeah, exactly. I'm leveraging everything I possibly can. So I'll be asking the panel some questions, and hopefully it'll be also educational for you too. So the first question I wanted to talk about is actually external security researcher engagement. Using my old playbook of traditional web-based security or services security, there's a pretty good talent pool out there who understand web apps, and it's pretty easy to go and test web apps. And there's a pretty well understood threat model. Like, you can explain that, yes, cross-site scripting isn't that big of a deal, but remote code execution is, and it's always bad. But in the case of hardware, it's actually a lot more challenging. So how do we get good hardware research in our products to have that healthy ecosystem?
I guess I'll cheat since I'm holding the microphone. I think that's a good point about the web application hacking, pretty commodity. The skill sets in the population, however, for hardware, much smaller, fewer people have that. But there's also even just simple logistical aspects of how do you get access to hardware. So something like Square and other commercial devices, those are pretty easy. They're not really niche markets. Go to Best Buy, go to any other store, pick up the device, start taking it apart. The catch, however, is what happens if you want to, devices start getting bricked. You want to be able to engage good faith reverse engineering. You want to be able to accommodate that so people can actually tamper in a way that they're looking for legitimate bugs, legitimate threat models that are like that equivalent RCE for hardware.
Yeah, I think I would say the same things. Cost of entry is pretty high for hardware researchers to find something. Especially the devices that we have in the production, in the field, are locked down. You won't have the same ports that are open on the dev devices. Also, they will have tamper resistance in it. They will have encrypted file systems and firmware and all that. So the cost of the initial effort that would be required to scratch all that and get into the chipset is pretty high. I think that is one of the reasons why it's very hard for hardware researchers to automate and scale all this. Other thing that I would say is, in terms of what can be done for improving the engagement, is We actually ran a private bug bounty program where we sent out the devices to researchers so that they don't have to purchase themselves. But again, that's not a scalable solution. Other thing that the conferences like these, where you have all the tools available for researchers and they can also have these devices available, I think that's a good start. Other thing possibly that bigger companies can do is maybe open up their labs that researchers can come in and try to hack their devices. So those are the things that I can think of.
So some of the stuff that we do at Intel is we also have a bug bounty program. Incentives for researchers can be monetary. There can be some people just want recognition. So having security advisories and CVEs that credit the people who do the work, I think, are very important. We've recently been doing a lot of training to go out and teach people all the weird intricacies of UEFI so that we enable them to find the type of things that we're interested for them to find. I know Intel also is giving academic grants for specific types of research that we're interested in and collaborating with different projects. So, yeah, there's a lot to be done.
Yeah, so, I mean, I'll talk about it slightly from the not as product developers and distributors, but from the offensive security side. So, yeah, we also do a lot of mentorship and training, and we have interns. In fact, for the last few weeks and for the next few weeks, we've got a big program going on internally at X-Force, where we've got interns and we're training them in this kind of stuff. And yes, the barrier to entry is high because of cost, but what you can do, and what we do a lot, is train on older technologies, because there's a lot of, the nice thing about all this new stuff coming in, there's a lot of churn. So there's a lot of crap that you can, I think I can say crap, can I? No? Oh, fuck. I shouldn't have said that. Oh, sorry. There's a lot of stuff coming on the market that, is out of date or obsolete or whatever. And so the techniques that you need to understand and learn, you can easily do on cheap disposable hardware, and they will still apply to new stuff. So it doesn't have to be a barrier. I mean, what I would always say to people who want to learn is just roll your sleeves up, do it, brick it, break it. It doesn't matter. There are some things you have to be really careful with on hardware. If you start playing with things like things that plug into the mains as opposed to a DC, you have to be a bit careful, because the ground may not be the ground you're used to. Sometimes they do it the other way around. So 5 volts is just 5 volts less than 240 or 110 or whatever you're running on. And that can go bang in a big way when you plug your probes into it. So be careful out there. So.
And so kind of a quick follow-up, any of you can feel free to answer. So it seems like a lot of the focus in hardware security research is on that kind of entry point for reversing to get to even understand how the system works. We're still spending a lot of time on that. Should we go ahead and just open things up? And if we really want to engage the security research community and provide more access to specifications, protocols, more detail?
Yeah, 100%. I mean, we can't help you if you won't help us understand your products. And normally all you're doing is making it a bit more time-consuming and costly. We'll get there in the end, reversing. I mean, we had a great experience but trying to look at the Nest products. We have an 802.15.4 sniffer, and so we're able to see all of the data being exchanged between the devices. But it's using thread protocol, and then Weave on top of that, which is proprietary. And so when I said to the guys, are there any decoders for this stuff? They're like, well, there's Open Thread and there's Open Weave, so the standards are public. Here they are. Go and look at GitHub. And we've got Wireshark protocol decoders. But no, there's nothing open source. We'll write that for you. So, we'll open source our Wireshark plugin, and we'll write you a Scapy module. So, because if you can't look at it. How are you going to help us figure out what we've done wrong? So yeah, definitely open it up.
So one of the first times in a panel where I've gotten an action item to go and work on.
Yeah, please go and authorize that.
All right, you got it. Any other? All right, shall we go on?
One of the things I love the most about my team is that even though we are within Intel, we're part of two big open source projects, Tiano Core and ChipSec. So that open is better.
All right. So as far as talking about the vulnerability management practices, so a flaw is discovered. And I'm using my previous job. I could iterate and get a patch out in a few hours, and all my customers are protected immediately. Obviously, that doesn't work the same in hardware. So, what should I be looking for as a vulnerability management practice, and how do I apply that same mindset in a hardware security program?
I'll jump on to that. I'll say one point will be maybe an allusion to something we'll talk about a little bit later, but maybe either a vuln or we'll call it a flaw that is touches on safety. So here's hardware that is going to spark, fire, something like that. That probably should be a recall. So that's maybe that's something we'll talk about in a second, because I want to jump over to that vulnerability side. One of the approaches we take is what's the exposure here? What's happening? Is this a compromise of a device or a compromise of an ecosystem? So compromising a device is important, but the threat around that, how we react, might be a lot different than if our entire ecosystem is done. So an example might be key material gets extracted. So does that mean that can we rotate something? So do we already have something to mitigate there within the hardware? So I'll just use that as one example rather than keep on going. So let some other
Yes, it can be really challenging for hardware devices to be fixed, right? So you have multiple versions of the same hardware device. You have different firmware versions on the same hardware, and not everything is in your control. The control is in the customer's hand. So you don't even know whether they're going to power cycle the device or reset the device or update to the newest version. Things that you can do is make sure that you have a good version control process. You have remote over-the-air update process built into your application. Other things that you can do is don't store secrets on your devices, right? So make sure that the secrets that you are storing on the devices are unique to the device, so that even if it gets compromised, you're not compromising every other device. Other things that you can do is plan for rotation already. So you assume that it's going to be compromised one day, so how are you going to rotate it? Those are the things that you can do.
So usually, even though the timelines to fix hardware problems are just longer because you have to go all the way back to the design, and there's way more teams that need to go redo all of their validations, the ODMs, OEMs, OS vendors, CSP, across the board. So that's why we have embargoes. But if we can figure out a way to patch or work around the hardware problem through firmware, that helps us have time, and also proactively shifting left in validation so that we can proactively find the things, so that when it does get reported, we hopefully already have a fix or we're working on one.
I'm very happy to say my only role in this is to create vulnerabilities for someone else to manage.
So it sounded like the idea would be is just to really build robust auto update capabilities, over-the-air updates, and thinking about defense in depth right off the bat. You can't iterate on defense in depth in hardware like you can in software. I can just keep adding things later, but in hardware, you have to think about that right off the bat.
Yeah, excuse me. I mean, you've really hit the nail on the head there. Hardware has to be secure by design. You can't come to a poorly designed product and sprinkle security on it. Software, you can gut it and fix it, but hardware, you really can't. You've got to start from scratch.
So, kind of pivoting to discussing software. So, most hardware by itself, ends up talking over an API, over the internet, looking and some of those protocols look like they haven't been necessarily designed with security in mind, or might be from like the 1990s. And as well, some of the inter-device protocols, like that are speaking between devices, oftentimes are a little dated. So how do you plan for dealing with those kinds of legacy problems?
I think a lot of the problems have come from a sort of earlier myth that hardware was some frontier that once it's in hardware, it's safe. And so a lot of bad things happened because people assumed you couldn't get down past chip level. Now we're in the fortunate position where chips are fast enough that we can actually do strong crypto without too much overhead. We've got separate crypto co-processors, so there's really no excuse anymore for having an unencrypted I2C or SPI or whatever connection between two chips, and you've got plain text stuff going on down at board level. You just have to design that stuff in and think about every single communication and egress point as being a threat and a risk. So.
I believe that the cornerstone of good security is a good threat model. So understanding what your assets are, how are they protected at rest and in transit, is important. And then delivering to that threat model, doing pen testing to see if all of your mitigations are actually protecting your assets. And so I guess this is an example of a cyclical growth of a new industry that's catching up to the state of the art, and it'll get there. But we need to be proactive and as well as reactive.
So one of the challenge in this is the adoption and migration, right? So you have the new protocol that has fixed the issue available to you, but you also have the old devices that are running the older protocol. Some of them cannot be even updated remotely. So now you have a mix of devices that are running the old version of the protocol and the new protocol. And sometimes if they are running in the same environment, you end up with the lowest common denominator in the security, right? So you have an environment where you have the latest gadget running in, which has the latest security on it. But again, because you have a mixed environment, you have the lower security. So those are the challenges in this respect. What I would say is that it's the adoption of the new availability of the new protocol, new version, adoption by industry, also the customer willing to buy the new product, and also service provider, how to plan the migration from old version to the new version. So those are the things that you should look into.
Yeah, I think I would echo the aspect of chips being able to handle, call it proper encryption, non-90s encryption, so that even, good end-to-end encryption designs are quite feasible and are, almost it should be a default expectation. So data goes onto the chip as early as possible in encrypted form, doesn't leave that form until it is processed somewhere back on the server. From the payments industry perspective, there's still a lot of interesting creakiness, or just imagine magstripe versus chip and pin versus contactless. So there's those aspects of protocols that we're still exposed to, but those are also, speaking of threat models, how do we make sure we don't exacerbate the problem? How do we make sure that however we take that payment information, that window is as short and small as possible between collection to encryption, and so that even with on the device, that a malicious actor can't pull that or compromise that off the device without some significant type of effort on their part, as well as, to broaden this up slightly more, it's not just a single device we're talking about either. This is actually an ecosystem, to throw out that word again, is that actors, they have motivations for some reason. Some of it may just be for the fun or for, compensation. And that's the fantastic part where they come into bounty programs. Other actors that are bad actors want to actually monetize this in some way. And if we have fraud detection, for example, that's pretty strong, that can minimize that type of monetization from a single compromised device, that's actually a pretty good mitigating control. And that's why we don't have to put to throw out that we don't have all the eggs in one basket, or whatever metaphor you want to use to say this is where the security only exists within this hardware model.
So kind of a follow-up to that, I mean, we talk about some of the industry bodies that set some of the protocol standards. Are you folks involved? Do you spend time with that? You want to kind of tell a case study of how that's been successful or not so successful from a security perspective?
Yeah, I've worked a lot in the UK on the smart metering industry, and without regulation and without standards, it would be a horrible, horrible mess. That's all. I mean, it's a horrible, horrible mess anyway, but it's less of a mess than it would be. I mean, yeah, I've been doing smart meters for probably 10 years, and it's only since the very latest standards have evolved that we're seeing anything that's even vaguely would come near my house, let alone in it. So I think regulation was really important there. And the development of the standards. And in the UK, it was an iterative process. Guys like us that were testing and ratifying the standard were working hand in hand with the government bodies that were setting those standards and saying, okay, this is not a good test, because all these use cases went through and it didn't catch it. So there was a lot of to and fro between the testing community and the implementation guys. So, yeah, that was really important.
Our team also contributes to some standards for resilience of platforms, and they're very generic, and they're meant to be. They're not a fix, but they're a good guidance. And like you said, just figuring out a way to actually have a concrete implementation of what we're trying to say with the standard is good.
Yeah, we do also sit on many standards. So standards like ZigBee, Z-Wave, Thread. There have been problems with older versions of these protocols, especially ZigBee, Z-Wave. We had insecure rejoin problem that the latest version has fixed. So we do advise them. We do sit on those panels.
I think I'd take it from the perspective, I'll throw PCI as a standard, but as an example that there's a lot of education that can be done is that technology, hardware, software has perhaps outpaced standards. For as much as I want to, could say that PCI is probably one of the things as PCI, Chrome, Mozilla, those are actually a standard in two browsers that have pushed the adoption of HTTPS probably better on the, across the internet than anything else. So just add that as a different perspective.
So I've got my to-do list, just keeps getting larger. So I got to figure out how to engage openly with this research community. I've got to build defense in depth at the beginning. And now you're telling me I have to work with all these regulatory and industry standard bodies? Whew, this list is getting pretty long. So traditional consumer apps are only now figuring out how to introduce real security and privacy choice and awareness and user interfaces and user research. So to actually understand like the choices that they're making from that perspective. How do we address this in hardware? I mean, to tell someone that the actions that they take as they interact with a piece of hardware has this particular security or privacy implication.
Jump on that real quick with to call attention to a recent article in Wired about the iOS and their Find My Device and encryption. So I think some great article to read on about the design of an encryption system, but I'm highlighting the idea of what data is being collected. Does it stay on the device or does it come off the device? Trying to say this problem is an aspect of user education or consumer education, is not meant to be try to get out of it, because educating effectively and correctly is hard, and it puts a lot of the burden onto the consumer to actually be informed and understand what you're talking about. But I think that at least has to be a very critical component to a list of things.
Yeah, so this can be, there is a lot of room for innovation here, right? So it does not have to be a difficult choice or where you have to put an interactive screen on each device where customer is choosing what data can be shared. It can be very simple thing like for a camera, you can always put a lens cover on it and customer can just use to turn it off. And all the speakers now have a mute button on them. So it does not have to be a very high cost solution. It can be a very simple solution that if manufacturers of device start thinking about, can put on those devices.
As a consumer, something that I'd like to see more of from the privacy perspective and on the hardware side are physical hardware kill switches for my camera, my microphone, my speakers, my GPS, because some of the RF kill signals can potentially be ignored. That's what I can think of on the privacy side.
So I think the issue now is it doesn't really matter how much stuff you put in subjectively for the user to make him think he's securing his privacy. Just the sheer proliferation of stuff that is leaking from everything we do now. I mean, it used to be that the government had to go to some lengths to put a bug in your house. Now you pay to do it yourself for them. So, people are falling over themselves to put devices that monitor them at all times and transmit stuff at all times. So it really doesn't matter what protections you put on the consumer device. That thing is going to be leaking stuff that something else can triangulate whether you want to or not. So I think we actually have to take a more holistic view of it and try and come up with a way that prevents that being abused. How we do that, I don't know, but it's not by asking the user, that's for sure.
So is regulation potentially an answer there?
Again, regulation will help people help to ensure the manufacturers do whatever we come up with, which is the right thing to do. I mean, if everything's encrypted and everything's anonymized and so on, by law, and you can test and prove that it's behaving that way, then you've at least made a start down that road. Mm. There are some things you can't possibly avoid. If I've got this radio mic, you can triangulate where it's transmitting from. You can tell somebody's sitting here. And if you can somehow map that to me on the camera walking through the door, facial recognition, blah, 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 there will always be a way around it. So, but we can at least raise the bar so that only the really bad guys can do it. So, yeah.
I think a regulation can be a solution, but it can also go overboard, and it can even kill the industry if it becomes cost prohibitive to implement that requirement. What I would think is that the thing that would really motivate industry to put these choices into the devices would be the strong demand from customers. So if there's a privacy-conscious customer who demands a certified, secure, and privacy-enabled device, that probably can move the needle. So bringing that awareness to our customers about privacy, security, I think that can go a long way.
I'll add to that from the aspect of, I'm going to be a broken record about threat models, but talking about this is that as we're designing, we can also be, what are we considering our threat models of? And it is just this malicious hacker or person who can show up at a hardwear.io conference and has access to the skills and equipment, or is it do we need to be even collecting data in the first place? So, for example, we might have a threat model in a point of sale system that we don't want a merchant to be able to trick someone who's buying a stick of gum, Coke, whatever they're buying, and charging them more. So there's a UI UX experience there that we want to make sure that, some malicious merchant isn't trying to overcharge or sneak in charges for their own sellers. And so we're working within a constrained environment of the UI UX, how to track that through. So it's a little bit of a shift from privacy, but it's that aspect of have we considered all the possibilities, and have we considered, so to speak, ourselves as another threat actor, so that it's easy for all this side channel information or incidental information, can that be subpoenaed, taken, extracted, collated, sold off to a hedge fund for all kinds of interesting information. So these are all kinds of things that we shouldn't just wait for consumer demand, which is equally important, but also push on privacy teams, security teams to build these into what they're, have these as considerations for when they're building devices.
And so I'll ask one more question, and then we can open it up to the audience who might also would need some guidance as much as I do. The first is kind of thing that I think about when I got into the space was like the Bloomberg story of last year of like hardware implants and all of those types of things. Like, how do you, as the experts and leaders in the field, actually design for untrusted factories, like the insertion or extraction of the key material that you want, or protect yourself against implants?
Well, when we're scoping out a project, we do include the supply chain in the scope. So we look at what modules you're using, how they get to you, what could happen en route, and can we create a base model for this thing? Can we do, or should you be putting a process in place to do random sampling and make sure that the device, if you take say once every 1,000 units, take a 3D X-ray of this module and compare it to the 3D X-ray of the one we tested, does it look the same? Are you running the same firmware, blah, blah, blah. So that's all built into the ongoing manufacturing process.
How many of your customers do that, do you think?
I can't discuss customers with you.
Oh, percentage. Just percentage.
I honestly don't know. I mean, it's a new thing that people are doing, but that's, at the top end, that's what you should be doing.
Got it.
Implants are interesting. Joe Fitz and others have debunked a lot of this mass hysteria of and like John Callis said yesterday, there are certain things that, yes, game over, nation state, like some things are just out of your threat model, and I think it's infeasible to analyze every component on every board all the time. Intel's an IDM, an integrated device manufacturer, so we have our own fab, so there's some of that handoff that we don't need to worry about. But I think things like link encryption are going to become more and more important to make sure that the components that are talking to each other are the components that we want to be talking to each other.
Yeah, securing manufacturing facilities can be hard, right? Few things that you can do is make sure that the secrets that you are embedding into your devices are actually being generated inside the device and not on the manufacturing chip. Other thing that you can do is, of course, you would have to have some sort of a PKI-based CA certification in there as well. So make sure that they are using HSMs. Other things that you can look into is, are there devices, are there computers that are building these devices are hardened? Or do you have you given them some security requirements that they are complying with? You can even audit them. I know NIST and NCMS have been looking into using blockchain technology to secure the distributed manufacturing. So in supply chain, right, you have typically you have designing the solution, designing the IP, and then you distribute it to your manufacturers, and then manufacturers build it, and then it goes into the field. So this whole supply chain has a lot of potential for any malicious thing to get into. So securing that, tracing it, making sure that information that is your IP remains confidential, that can actually be secured using blockchain.
Yeah, I think I just echo that aspect of that we need trusted enclaves to actually be trustable, because a lot of the key generation and having that type of device self-attestation is really what helps with a lot of that aspect. And I think what I'll also do is maybe, because I think what I've heard mostly is it's really a process issue right now, and process solution, I guess I should say, because you can't you go and check every device. But by the same token, perhaps, I'll sidestep by saying there's side channels, there's other aspects of these devices that may have just information leaks anyway, that you don't need to actually do a supply injection attack, that if there's already creaky parts of it or brittle aspects of it anyway. So, I just putting that into perspective.
I feel a slight undercurrent of despair here, but it does seem like it is a challenging problem. So let's go ahead and open it up for some questions. We have a few minutes. If anyone wants to ask.
Do you ever, this is weird talking to Mike, do you ever think Intel and AMD will release a bunch of documentation pertaining to like the inside of their chips and like things like that? Because, you know, like speculative execution and bugs and all that, like those research and a lot of that's like done at the highest level, and nobody has access to that except like University of Michigan and like, you know what I mean?
I can talk for the BIOS team, and I know our new GM is all about open sourcing and pushing and challenging, why can't we open source this? So hopefully we're moving in that direction, but I can't make claims for Intel.
So a lot of the talks at this conference have been about reverse engineering, and it sort of seems like at the core of reverse engineering defeats a lot of the silicon security defensive mechanisms we have in place. Or I'm just wondering, how do you guys think about that, and how do you think about that as part of your product security?
I'm open source, man.
Yeah, I think I'll throw out the Kirchhoff's principle that, you know, the openness of the design, if the knowledge of the system shouldn't defeat the system. And so I think from my perspective, we are hoping that trusted enclaves that has guarantees and security boundaries in terms of protecting key material, but otherwise access and knowledge of chips shouldn't, weaken the end-to-end encryption, or shouldn't, significantly expose an avenue of attack that is meaningfully different from attacking the OS, or otherwise having physical access at one of the different layers.
Yeah, I think I would echo that. The threat modeling is very important, right? So you need to find out what are you trying to protect in that device. Are you trying to really protect the code? Are you really trying to protect how it works with the cloud? Or are you trying to protect some secrets in the device? Of course, there are things that you can do. You can embed a secure element into it, which would be hard to reverse engineer or hard to break, and you can store your secrets in there. Also, as I mentioned before, plan for information to get leaked. So don't put secrets into your devices that are common to all your devices. So even if someone is able to reverse engineer it, they would be able to only leak one secret at a time.
I'm a hacker. The harder you try and protect it, the harder I'll try and break into it. So, and same goes for everyone else out there. And
that's a good, healthy challenge, right?
Yeah.
There'll always be somebody, as long as there's something to gain, we're never done with security. And one of my favorite security quotes is, there's no such thing as security, only varying degrees of insecurity. So you draw the line somewhere and you try again every day. And that's all you can do.
So I got a question for you. Starting in 1996 and culminating somewhere around 2010, we defined the TPM 1.0 standard. And in there, we kind of thought the remote attestation is going to be a very interesting function. And so since you hack devices, you look at them, especially in the IoT domain. Is there a format we can follow where they actually do use remote attestation beyond a cryptographic fingerprint of an image, beyond the chip info, like manufacturer? How useful is it?
I'm sorry?
How useful is it?
How useful is it?
The actual remote attestation. Like how many implementations take advantage of the code report? Huh? So then how do you decide which device to trust? I mean, you guys talk about standards, certifications, trust but verify. How do you do it?
I mean, yeah, there's, for UE5, we have a bunch of stuff, right? And the hashing and verification of signature for our code and boot guard, and there's all kinds of fun
None
features.
of those technologies are on MCUs. Who implements UE5 on MCU? Are you aware? So this really is a question for the hacker community, not for the designers or architects.
I'm not quite following the question. I mean, I do like the way you presented it. It was very dramatic.
Thank you.
Towards us. I mean, the way we verify is by testing. So, we take the principle that you've secured the device, and then we try and prove you wrong. So that's what I do, and that's what we as a hacker community do. We try and think like the bad guys, and we try and break it, and we don't really care what the standard said or what number it's filed under. Does it do the job it was designed to do? That's the only question I have to answer. So.
From an implementation perspective, yeah, that's true. And especially if you're looking at it at a physical perspective and got it in your hands. But if you're looking at the IoT devices that are deployed primarily with remote interfaces and attack surfaces, the way they talk to each other from different manufacturers, right? There has to be some sort of a protocol and some sort of way to say, I trust it, right? Like, this is the information you need. So what I'm wondering is, what you can get today, how useful is it? Is it out there that's being used? Are you seeing it if you're hacking it over the network interface?
You mean a standard for the communication? For
the remote at-the-station report, yeah.
Yeah, I mean, well, we have a bunch of standards like TLS and encryption standards and so on that people adhere to. Key exchange protocols. There's all standardized.
Yeah, that's all security
industry,
crypto, not remote at-the-station. So no, none of you are aware, huh? Thank you.
Any other questions? Can we take? Okay. We're still open for questions. If you're done.
Great. Well, thank you everyone for the time, and I appreciate the panel's advice. And I'm looking forward to maybe reaching out and asking for advice continued on. So thank you all.
Thank you.
Thank you.